Yeah.
So, problem number 2. The hardest part about problem number 2 is where to start. How do you set up the problem originally? The first thing is I'm going to factor out the polynomial. So x plus 1 times x minus k turns into x squared. Well, let's see here, minus kx plus x minus k. And I can take the like terms, all right, and factor out the x. So this becomes x squared plus 1 minus k x minus k. So we think of this 1 minus k as a number, right? That's just some random coefficient, right? Like 3 or negative 8 or something like that. And then it says when you divide by x plus 2, right, your remainder will be 7. So what we're going to use, and this is the hard part, we're going to use synthetic division for this. Anyone remember synthetic division? Maybe, kinda. Yeah, it's been a while. Here's the deal with synthetic division. We take each coefficient and write them in the column. So the coefficient on x squared is 1. The coefficient for x is 1 minus k. The coefficient for the constant is negative k. And then when you do synthetic division, you take the number you're dividing by. So if you're dividing by x plus 2, anyone remember what number I plug in here? Negative 2. Right? Good job, Joe. So it's always the opposite. So for example, if I change the quiz to x minus 2, you would turn this to plus 2. That make sense? All right, so that's how you do it. And now in synthetic division, we bring the 1 straight down. We multiply. Negative 2 times 1 is negative 2. We add this column straight down. 1 minus 2 is negative 1 minus k. Then I multiply negative 2 by this term. So the negative 2 distributes to give us 2 plus 2k. And we add this up, and you get 2 plus k. Well, 2 plus k, that's the remainder, based on synthetic division. So we say 2 plus k must equal whatever the remainder is. And what did they say the remainder was? 7. All right, so that means that k equals 5. All right, so the hard part there is synthetic division.